Okay, hello. So we continue with the next part, which is MOSFET or power switch. So if you can see here, this is the power switch. Okay, so this is the power switch. So the power switch for power electronic application, you can choose either MOSFET, okay, or IGBT. Okay, MOSFET if you want to switch at higher frequency. Okay, so if you have 30 kHz, MOSFET, you don't care about frequency. Okay, frequency can be anything, but for IGBT the frequency needs to be less than 30 kilohertz. Okay, because IGBT is a little bit slower. Okay, that is the limitation of IGBT. But the advantage of IGBT is the power. Okay, the drain ID means that the current passing through here, maybe I call it IM. Okay, so IM can be very large, and the VGS, okay, not GS, okay, yes, VGS means that plus VGS minus is very small. Okay, so the advantage is you can use it IGBT for higher power application, and of course the loss is much more lower, but the frequency needs to be very low. But for MOSFET is very high frequency, that is the advantage, but there is a limit on the current. Actually it's called sorry, not VGS, VDS. Okay, VDS. Okay, VDS is small, so this one is called not IM, ID. Okay, drain current. So ID usually is much more lower. Okay, not, you cannot apply for very high power, but for FYP usually, and for research usually we don't go too high. Okay, still okay, you can use MOSFET. But the problem with the MOSFET is RDS on. Okay, that is also a problem. RDS on is basically power loss equals to ID squared RDS on. Means that the higher the current, the higher the losses. So P loss is exponential. But for IGBT, P loss is equal to VDS drain source IDS. So the power loss will be linear. Okay, so around linear. Okay, not exponential. So that is the advantage. So make sure you choose properly, and of course IGBT is much more expensive. Okay, much more expensive. Okay, so recently there is another types. So this one is made using MOSFET. Using silicon. Okay, now there are a new one, gallium nitrate, if not mistaken. That is a new one, gallium nitrate and silicon carbide, I think it's called. It is a new material, and this one is much more expensive, around 5 times more expensive than this. So depend on your research, if you are focusing on efficiency, I suggest you use this, but it's quite expensive. For normal research and don't care too much about the efficiency, you just use silicon. Okay, this one is cheap, around 5 ringgit. Okay, 5 to 20 ringgit. But this one usually around RM 50 to 200, I think. And another thing you have to consider, either you want to choose the body. Okay, I think it's called a casing. Okay, casing, either the standard TO220 or module. This is the standard one. TO220 is usually the size is almost like a thumb. Okay, your thumb. But for module is very large, maybe large like a head. Not the head, like a, yeah, like your hand. Okay, the size. Okay, and module usually around RM 300. Okay, but for TO220 or around this class is around, like I said before, this price. Okay, so this is the TO220, but for module is much more expensive, but the rating is very high. so you can use it if short circuit or something is will not damage. So that is thing that you have to consider when you buy the MOSFET. Okay, so let me copy this first. Okay, so when you want to buy a MOSFET, there are usually three things you have to consider. Okay, first the VDS and frequency. Okay, usually three things. Okay, so for ID, of course, you have to look at the current that passing through the MOSFET during the turn on. Okay, so if the current, for example, the maximum current is around 5 ampere, I suggest you choose around 10 ampere. Okay, minimum is, like I said before, safety factor is around 1.3 to 2 times. Okay, this one should be enough. If you want more safe, much more higher. So that is the rating. So for this case, I think just set to 10 ampere. Okay, so VDS. So for VDS, you have to measure the voltage across here. Okay, so you have to put during the simulation, you have to put the voltage measurement. Okay, you have to measure it. Okay, same here. I suggest 1.3 to 2 safety factor SF. Okay, so for example, if this one is if you measure, make sure you measure, don't just look. Okay, sometimes if you have transformer, it can double your source. Okay, for example, this is V in. Okay, if you use flyback, for example, okay, for flyback, V in is 100, so VGS needs to make sure it can withstand 200. It will become double. So that's why I suggest in simulation you have to measure. Okay, because some topology can make the voltage double. So for example here, if the voltage here is 50, I suggest 100 volt. Okay, that is the rating. And frequency, you have to look lah. If you are switching frequency more than 30k, this one you must use MOSFET. Okay, but less than 30k, okay, if you are you want to make sure that system is very efficient, you use IGBT. Okay, IGBT is much more efficient. If you don't care too much about that and you want to save money, okay, IGBT, remember, is quite expensive, and you can just use MOSFET. Okay, MOSFET is cheaper, and of course it can, okay, if you don't care about the efficiency, it should be okay, and it can withstand high frequency switching. Okay, so you have these three parameters, then you can go to top one. Maybe you can search for it, MOSFET. Okay, but usually top one only have normal types of MOSFET, usually low rating. Okay, low power rating. But if you want high power rating, so you have to search here. So for this case, I choose MOSFET. Okay, if you want IGBT, just type IGBT here. Okay. Okay, for MOSFET, I think they have enhanced and depleted, and have N channel and P channel. Make sure you choose N channel. This one depend on your application. You can read about it, okay, but usually I use enhance N channel. Okay, so let me show you what is N channel. P channel is depend on the direction. N channel is the normal direction here. Depletion, enhance means that if no GS, I think it will be open loop. Okay, let me check first. So this is the enhanced type. Okay, so this is the N channel. The symbol also different. Okay, this is the depleted MOSFET. I think if this one will become short circuit if no gate, something like that. Okay, but usually we use the enhanced N channel. Okay, enhanced N channel, make sure of that, because different type will show different properties. Okay, very different properties. So of course MOSFET search. Okay, so like I said before, if you want to buy a module, okay, this one is very high power and it's very hard to damage, you can use this, but it's very expensive, around 300 ringgit. But if you want to use a simple one, you can use IGBT here, or you just use transistor. Okay, for this case, IGBT, like I said before, also quite expensive, so I use transistor. Okay, and of course, I remind again, avoid using SMD for your for application in UTM. SMD is not very good. Okay, we don't have enough equipment to do SMD, surface mounted device. So I suggest you search for this type. Okay, you need to drill a hole into the PCB. It's called DIP. Okay, deep. Okay, this one SMD. Okay, so you go here. You try to find. Okay, sorry. It should not be transistor. It should be FET. Okay, so MOSFET is under FET. Okay, so you should click the MOSFET. Okay, and this one is the expensive one, like I said before. This one is much more efficient, very efficient. Okay, for silicon is 0.7 volt the voltage drop, but this one is 0.4 only, around that. So if you want to focus on that, you can choose this, but it's very expensive. Okay, silicon carbide also quite expensive. Okay, so I suggest you use just this one is the module. You can even to use module, also very expensive. So I suggest you just choose single MOSFET. Okay, so like I said before, you take the current and voltage, 10 ampere, 100 volt. So I suggest this one, drain current, IDS. Okay, drain current, so it's around 100. And like I said before, don't just click 100 because it will become very limited. Okay, so maximum is 200. Okay, you also have to put the maximum because if not, the expensive one also come out. Okay, you also have to make sure the budget is within your limit. Okay, so you have the voltage. Okay, and then you have the current, 10 ampere. Okay, search for 10 ampere. Okay, and then the maximum is okay, where's the 10 ampere? Okay, this one maybe 14. Okay, make sure you have at least, okay, this one is good because you have still have 1000 product. So search. Okay, so for this case, I suggest you try to find RDS. Okay, you have to minimize the RDS. RDS is basically resistance in the MOSFET. The lower the resistance, the lower power loss. Okay, so search for RDS. Okay, it's not available, I think. Wait. Okay, this one, drain source on resistance. So this one, the lower the better. Okay, so and of course next you have to look at the availability. Okay, availability, and you don't want this one, SMD. This is called SMD. We don't have the capacity to do it. Okay, so try to find to avoid. This one is also SMD. Try to find DIP, or you can just choose here. I think they have the body type. Okay, okay, unfortunately no, should have here, but I'm not sure where is it. Okay, so next you go for next, make sure it's not okay. So but this one no longer manufactured, you cannot buy this. Okay, so this one is quite good. This one is page 2, should be page 2. Okay, we have to make sure that RDS is quite low. Okay, so this one available 3 is dangerous. Okay, don't buy it. Okay, search for it. Okay, this one 225. Okay, quite okay, and the RDS is quite small. but the voltage is not correct. Okay, the drain source voltage is not correct. I think it's failed to register here. Okay, unfortunately it failed to register, so you have to do it again. Okay, maybe the previously it hang. Okay, let me check back again. Okay, so this one, the filter is quite good, but you have to make sure that it's available. Okay, and not SMD. This is SMD, you cannot use it. Okay, this one is too small. Okay, this one is quite good, but it's SMD. Okay, find more. Okay, I think it's quite good for this. You can see here it is a DIP type, means that you have this one. Okay, not SMD. The availability is 2700. Okay, this one is good. Okay, you have 100 volt. Okay, 80 ampere is quite high, but the RDS is quite low. Okay, 0.06 is quite low, and the body type, the casing is the TO220. This one is good. This means this is type. Okay, so this is the standard. Okay, but it's still very expensive, 30 ringgit. Okay, for this voltage, okay, you have to usually it's only around 5 ringgit. Okay, let me try to find another much more better price. Okay, I'm not sure why today has problem. So if you have problem, you just click the voltage you want, 100 volt 10 ampere. So this one is quite good. Okay, 100 volt 10 ampere, 0.18. so the internal resistance is quite high. Okay, 0.18 is quite high, but the price is only 4 ringgit. But if you want to improve your circuit, I suggest you choose less than 0.1. Okay, less than that. So, but if your application is not too critical, maybe you can use this. Okay, so click this. Okay, copy it. Depend on your application. If your application is quite important, you have to make sure that RDS is very small. 0.01 is much more better. But if you are for FYP, it's not too critical. So you can just put here. Okay, for this case. Okay, depending on your application. Okay, also element 14. Okay, if you use one, for example, this one only use one MOSFET, I suggest you buy 3. Okay, MOSFET easily burn. Okay, I suggest 3 also usually not enough. 4 is minimum. Okay, so the price again, check back, 474. 4.74. Okay, so this is the price. Okay, like I said before, be careful. If you want to make sure your system is very good, choose this lower, but it's much more expensive, around 50 ringgit. But if you are only do FYP, 0.18 is enough. Okay, so that's it. That is how you buying the MOSFET for your application. Okay, thank you.